Okay, in this lesson we're going to go over midpoint, slope, and distance of a line. So all formulas you had to use throughout this chapter, we're going to put them all together to solve geometric questions. So in the very first question they're asking us to prove it's a right angle triangle, and by it they mean this triangle AB, and there should be a C there. Okay. So the first thing we want to do is plot all of these points. We go down to our graph, triangle 5 and 5. That is point A. Point B is at 1 and negative 3. And finally, point C is at negative 3, negative 1. So we can look at this and make an assumption. But for all we know, and first of all, where would you assume the right angle is if this is a right angle triangle? It's probably at B, right? If it is one. But by looking at it, we don't know if that's actually 90 degrees. For all we know, it could be 89 degrees, just 1 degree off, or 91. So we need to actually go about proving this. So the first method we're going to use, how do we prove if something is a right angle or perpendicular lines? What are we looking for? Midpoint takes us to the middle of the line. It's one of these three things. We're going to either use midpoint, slope, or distance. Slope. And what do the slopes have to be? Negative reciprocals. Okay? So in order for these, or for this to be a right angle, we need a line CB. Okay? And we need line BA to be negative reciprocals of each other. Now,
What do you mean by that?
you'll see. So, CB and BA, we need to prove they're negative reciprocals or perpendicular to each other in order for this to be a right angle. We're going on the assumption that CA is not included in one of the right angles, but just to be sure, what we're going to do is we're going to find the slope of all three of these. Okay? So, the first thing I'm going to look for is line CB. So line CB has these coordinates here. And remember our slope formula, we'll actually write it out. It's not y equals, but m. y2 minus y1 divided by x2 minus x1. Okay? So we're going to look at those slopes here. So this point here was at negative 3, negative 1. And this point here was at 1 and negative 3. We'll take those values for the very first slope for line CB. And we'll plug it in. So slope is equal to. And I'm going to quickly call this x1, y1, x2, y2. Okay? Our y2 is negative 3. Subtract y1 is negative 1. Divided by x2 is 1. Subtract x1 is negative 3. Okay. From there, negative 3 subtract negative 1 is negative 2. And 1 subtract negative 3 is 4. In other words, the slope of this line reduced is negative a half. Okay. Now, the next thing we need to check is we're going to look at AB. If AB is not a negative reciprocal of this, we'll go ahead and check CA. It's most likely not. Okay. But let's check this first, because if CB and AB are already negative reciprocals, we know we don't have to check the other side because you can't have two right angles in a triangle. There could only be one. So the next thing we're going to work with are these 2 points. This point here was at 5 and 5. I'm going to rewrite this one in blue again just so you know that I'm using it for a different line. Okay? Again, I can still call it x2 and y2, and I'll call this x1 and y1 for this question. So the slope of AB in this case is equal to y2 was negative 3, y1 was 5, so we subtract the number 5 from it. And x2 was 1, and x1 was 5. I said that backwards. We plugged it into our formula. Negative 3 subtract 5. Yeah, we get negative 8 divided by 1 subtract 5? Negative 4. What is negative 8 divided negative 4? 2. Now, just to prove this is a negative reciprocal, how can I write 2 as a fraction? It is 2 over 1. So if you guys quickly look, this fraction has been flipped upside down, and this is a positive term, and this is a negative term. Proving that this is a negative reciprocal. In other words, this corner here is a right angle. So we've just proven that this is a right angle triangle by just looking at the slopes of our lines. 5 minutes? Okay, good. Now, there's actually another way we could do this. Another way we could solve this question is actually by looking at the distances of all these lines. Okay? We can use our distance formula to solve them all. And you know what? We'll do that in another question. We'll do the same question again using distance.